Let's solve the problem of finding tan of sine inverse of negative square root of 3 over 2. We'll break this down step by step using trigonometric identities and properties of inverse functions. First, let's understand what sine inverse means. When we see sine inverse of some value, let's call that angle theta. This means that sine of theta equals that value. In this case, sine of theta equals negative square root of 3 over 2. Now, let's visualize this in a unit circle. Since sine of theta is negative square root of 3 over 2, and this value is between negative 1 and negative 0.5, theta must be in the third or fourth quadrant. Given that sine is negative and its magnitude is root 3 over 2, theta must be in the third quadrant, specifically at 210 degrees or 7 pi over 6 radians. Now that we know theta, we need to find tangent of theta. Recall that tangent is defined as sine over cosine. We already know sine of theta is negative root 3 over 2. To find cosine of theta, we can use the Pythagorean identity. Sine squared plus cosine squared equals 1. Let's solve for cosine. Substituting what we know about sine, we get cosine squared equals 1 minus 3/4, which is 1/4. Taking the square root, we get that cosine of theta equals negative 1/2, since in the third quadrant, cosine is negative. Now we can find tangent of theta. Substituting our values into the tangent formula, we get negative root 3 over 2 over negative 1/2. The negative signs cancel out, and when we divide fractions, we multiply by the reciprocal. This gives us root 3, which is our final answer. And that's how we solve this problem, using trigonometric identities and properties of inverse functions. Remember to visualize the angle in the unit circle to help determine the signs of the trigonometric ratios.